Welcome, everyone. You are listening to The Cyber Riddler, a podcast that talks about offensive and defensive side of the cyber world. I'm your host, Ahmed Mrabi. Usually, when there is a new technique or we have a technique in mind, when we try to code it, we try to go and search blogs in the internet and try to find something. Either we have a DLL injection technique or thread hijacking or any of the cool techniques what we have. We just search for it and then we find some tutorials that close enough to our concept. And when we have it, we just copy the code or paste it, and that will be it. And that's it. But what happened is, if we have a new techniques in mind, or we have a new concept that we want to implement, then we cannot find a tutorial that will tell us exactly what to do. So that's why we try to go back to the documentation, go to square one, square zero, if you may, and try to go to MSDN, try to check the functions and how they work. And sometimes we spend days, weeks, depends on the experience that we have. Today we have a guest that he's famous even in Twitter, and he's famous when it comes to Windows internal. And I'm personally happy. I'm personally happy that I have him in the show because I followed his tutorials along the years, and I tried my best um, to follow him on Twitter, to try to understand the latest techniques, to understand what he can offer. And I'm glad to have him in the show. He's one of the people who wrote the Windows internal book for Windows. And I want to welcome Pavel Yosifovich to the show. So welcome, Pavel.
Thank you, Ahmad. Glad to be here. Uh, I'm Pavel. I've been doing lots of things in the past few years. Been doing some training, writing some books, blog posts, and I have a bunch of tools on GitHub, which are mostly open source, which provide some insight into what's going on inside Windows. I like to write code, and I see that as a creative activity. So that's where I'm coming from, essentially.
That's awesome, Pavel. I think you just gave a humble description or briefing about yourself because sure enough, you did extra. You did more things that you're humble enough that you didn't talk about. Man, I think maybe half of the internet followed your tutorials when it comes to Windows internal. So I'm glad to have you here in the show. So today we have a couple of things. We have a couple of topics that we want to discuss, and it's mainly about Windows internal for sure. And before we start, I like always to start simple for people to follow, and then we can go to more deeper stuff and complex stuff. So
Right.
usually I want to talk to about user space mode and kernel space mode. And sometimes we can see that applications running in user space will be doesn't have much privilege than kernel space mode. So can we give an idea about these modes?
Yeah, so a typical operating system has these two modes, user mode and kernel mode. And the kernel mode is where the kernel actually is. And the purpose of the kernel really is to control the system or to provide arbitration, because you can't just let any random process do whatever it wants. It has to go through security checks. It has to arbitrate accessing shared resources like RAM and IO stuff and memory, things like that have to be managed by someone, and that someone is the kernel. So the kernel has the most privileges on the system. It can do anything, essentially anything it wants. Where we live typically when we run applications like Notepad or Explorer or whatever, we run in user mode. And so we want to do stuff. And for this stuff, we have to ask the kernel's permission, really, whether we're allowed to perform this operation. If so, we'll be able to get our way. But obviously, the kernel has the final say. So, for example, if, say, Notepad wants to open a file, Notepad can't really open a file in its own. It's not really possible. It has to be done by various kernel components, such as the file system driver and disk driver and things like that. So we have to have a call that starts in user mode and then goes into the kernel, and then the kernel needs to make the decision whether, in terms of security, the calling process is actually allowed to access the file that it's being requested, and if so, what kind of access it should get, and things like that. So user mode is restricted, and again, that's on purpose, so that no single process can kind of take control of the system. and the kernel has to manage all the resources and make sure that every process gets what they need, but not more than they should get. So that's the
Oh,
kind of the easy way
is
to
it
describe that,
definition to
perhaps.
it? Yeah. Okay. So what are the examples of applications or processor or operation running on the user space mode? Like, is it like every
So
single
essentially,
application or?
yeah, any most processes, if you look at something like Task Manager, you see lots of processes there. So they're all running in user space. At least they start to in user space because this is where we can write our code and say, well, we want to open this file, we want to create this thread, we want to load this DLL, we want to do stuff. So everything starts with user space. There are some special processes which actually are kernel processes, such as the system process, which represents whatever is going on in kernel space. And there's a secure system process, which is representing the secure kernel for systems that have virtualization-based security running on their system. So these are kind of special, but most processes based around some executable, they're the ones that try to do stuff in Windows. And this is where they start. They perform an operation. They try to perform an operation. This goes into the kernel. The kernel has to make the decision and provide the result to the operation.
Okay, but then can user space mode access directly a kernel space, or we have to have a driver? We will go in depth on all of this. I'm just try to give some of the things we can talk about. Yeah.
Yeah. So the short answer is no. If user mode could access kernel mode without any, I would say, well-known or official paths, then what would be the point? I mean, if I could go and access anything in the kernel directly in some way, then the kernel is kind of useless because it means I can bypass the kernel. And so the idea here is that there's these paths which you are allowed to use to access the kernel, and these are known as system calls. So the system call is a mechanism that makes the transition from user mode to kernel mode to ask for a certain operation to be performed. And this is where you always have to go through in user mode, unless there's a real bug in Windows, which these things happened from time to time in the history of Windows, but they've been patched very quickly. And so you always go through these system calls. There's no other way. And that system call could also talk to a driver. So if you have managed in some way to install a driver on the system, then essentially you have the powers of the kernel, so you can do anything you want if you have your client application talking to the driver. So essentially the system is practically yours.
Okay, so as you mentioned, so we cannot even if the developer want to access kernel space directly, he cannot do that because either he have to go through a driver or go to a system call, but he cannot just go. There is no other mechanism to go directly to the kernel space. But how is like the operating system ensure that the code will stay inside between the space user mode and the kernel mode? How the system will ensure the integrity of it, and when there are things like buffer overflow and things that you can do in user mode that go to kernel mode.
Well, first, the essential mechanism is provided by the processor. So if you look at the address space of a process, let's say on 64-bit, it's 128 terabytes, you have that address space, but the kernel address space is in the upper 128 terabytes of the address space, and these are not the same addresses. And so if you do want to access one of these addresses, they are marked by the processor as requiring the call privilege level 0. And user mode runs with call privilege level 3. And 0 is more powerful than 3. And essentially, the hardware prevents accessing the kernel memory directly. So you get an exception essentially, and you just can't do it because this is where the CPU has this concept of privilege levels where it can say, well, this part of memory is only accessible to this kind of code, the code that has more power. So it's actually prevented on the hardware, directly by the hardware.
So that's why when we go, we always refer to it. And correct me here if I'm wrong. We always either in Twitter and refer to it as ring 0 and ring 3. But is it like ring,
Yes.
or is it like from or Intel perspective, or we usually say ring 3 and ring 0, right?
Yeah, so these terms are coming from the Intel processors, and
Yeah.
so they're specific to Intel world. But regardless of which processor you're looking at, there are at least these two privilege levels at the very least, the user privilege level and the kernel privilege level. And so on Intel terminology, it's using with 0 and 3 as the terms rings, but on other processors, it's the same idea. You have Intel actually supports 4 level of access, but only 2 of them are used on Windows. This is for, well, it's an historical thing because in the old days there was the Alpha processor only supported 2 privilege levels, so Microsoft had to go with the lowest common denominator, and this remained until this day. So there's always at least 2 privilege levels. And
I feel like Windows like always to keep their legacy code and backward compatibility. Even their folder directories, System32, which wow 46, all 64, all of this
yeah.
they keep this and as for compatibility issues.
Yes, usually when you ask about Windows, why is something in the way that it is, 90% of the time the reason is compatibility. So,
Compatibility issues. They love compatibility so much. Yeah.
yeah, it's very important to Microsoft, and it makes sense because there's so many applications out there. It's very difficult, and when they change something in a significant way, we've seen that in the Vista days. Many new features coming on in Vista that broke lots of applications from the XP days because some of the compatibilities there weren't perfect. That was one of the reasons, and so Microsoft cares about compatibility a lot. And on the one hand, it complicates things and sometimes bugs are not really fixed because of compatibility concerns. That's kind of silly, but it is the way it is. On the other hand, it makes sure, at least to a large extent, that existing applications continue to run even in newer versions of Windows without needing to change. It's a big
Okay.
ecosystem.
Big ecosystem, that's for sure.
Yeah.
Okay, so usually I have a question. This is from my curiosity. Is there like a common example, or there is an example not from security related? Is there is example of where a developer need to call user space, a kernel space from a user space perspective as transitioning from that, as they call it CPU switch? Is that correct?
Um,
They call it
Well,
CPU
it's
switch,
more of
right?
a mode switch. I'm not sure CPU switch is the
That's the
term.
term.
Um, so it's more about mode switching. The mode is switched from user mode to kernel mode, or there's a transition in ring levels or called privilege levels. There are many terms that are used around this space, and they all mean essentially the same thing.
Okay. So we just covered now things for kernel, things for user space. We will go back to that for other complex stuff with the EDR, but just understanding the idea for our audience here, just understanding the idea. So I have another subtopic in mind for that. So about hooking, what is hooking in general, and what is the purpose of it?
Right, so hooking in general is the idea of interception, the ability to kind of get notified about certain calls or certain things that are happening before they actually happen. And so hooking is a generic term. There are many types of hooks that the Windows supports officially and some types that are not supported officially, but still people are doing these kinds of hooking. And in all cases, the goal is the same, is to be able to intercept certain calls and look at the calls and see whether you like it or you don't like it. Obviously, for security purposes, that's one of the ways that security products try to figure out what processes are trying to do. And based off that, they make certain decisions, maybe block the call or maybe call the original function on the original thing that they're hooking. Um, so that's the basic idea. It's trying to intercept what is going on. And this could be done in use mode, could be done in kernel mode, and there are several ways of doing that. Probably the most or the simplest perhaps to understand is to kind of divert a function from where it's supposed to call to a different location. And so when someone calls a certain function, let's say write file, and the code of write file is replaced, at least the first part is replaced with a jump instruction to a different location, and that's going to call the actual hook that is provided, the alternative code that we would like to run. and that code can look at the right file parameters and say, well, I like it either or I don't like it. If it's all good, it will usually call the original function. And if not, it might want to log things or block the call or things like that. So this is done a lot by EDRs for sure in user mode at the very least.
So usually, is there a way we will go back to the EDRs, but usually in a normal development, like these hooks always like related to EDRs or cybersecurity related stuff, or usually a developer, a normal application can do hooking as well, or they can take advantage of hooking in a normal development, not in a cyber world.
So yeah, I mean, normal development can also take advantage of hooking for legitimate purposes. And as an example, I was working on the sysinternals tools at the time a few years back, and one of the things I did there is generate this dark theme that certain sysinternals tools support, like Process Explorer, Process Monitor, things like that. And to implement dark theme, unfortunately, it wasn't very easy when we're using the Win32 APIs because the normal Win32 UI doesn't really lend itself into easy theming. And so I had to actually hook several APIs in order to make changes. So if someone wanted to draw something in white, I changed that to black or something like that. So I had to actually use some hooking in order to implement theming, to implement the dark theme. So this is like normal
Legitimate
thing.
purpose.
Well, not really normal, but not a security-related purpose at the very least.
But usually, so in a normal development or a legitimate development or any normal development, let's say, people can actually use it, but EDRs use it in a matter or in a sense of hooking functions, so they can block or intercept any call. So these DLLs, for example, for API, and they can either block it or prevent the call, or they will check it. If it's harmless, they will just make the call. Continue, otherwise they will just prevent that code from happening. So usually EDRs will be hooking every single DLL, or they only hook certain DLLs like the NTDLL, the kernel based DLL, and kernel 32 DLLs.
So usually, well, EDRs in general, they have usually two components. One of them is the kernel driver, and the other one is stuff in user mode. Now, in user mode, in many cases, they will hook certain APIs. They will not hook everything, and they will not hook every function in a particular DLL, simply because hooking is kind of dangerous. It's risky, because if you mismanage something, you might cause a crash for the client process. Obviously, customers will not like it. There's also the cost of that, because there's now extra code running for every time you call this particular function. So it might have performance implications, because then the code there says, well, is this a legitimate call or not? And that kind of processing might be expensive. And so they only try to hook what they must. Usually that's going to be NTDLL. Because eventually, if you hook things in kernel 32 or kernel base, they will call NTDLL anyway. So why not just use NTDLL and be done with it? It's going to be simpler, less hooking happening, and sometimes malicious activity can bypass kernel-based stuff and call NTDLL directly. And that's why typically, I think, well, at least the more prominent EDR products will not hook kernel 32 or kernel base, but go straight to NTDLL, because this is eventually the last step before actually going into the kernel.
Okay, so they usually go for the NTDLL because most of the applications will just inherit or import NTDLL to their application, so that's why they will be easier for them to
NTDLL
check.
is actually a must-have DLL. So it's actually being mapped by the kernel to every process. So every process must have it. So there's no way to kind of get rid of that or anything like that. And that's why it's the lowest common denominator that is convenient for hooking purposes.
Okay, but so as a hacker, I cannot just go and unhook NTDLL because of the EDR is hooking it, right? There are ways, but I mean, in normal way, just thinking from abstract standpoint, you can just unhook it and go directly to it,
Yeah.
to the other applications.
Well, Unhooking is definitely possible. It might not be easy, but it is possible because if you are inside a process, you manage to get some code into the target process, then you have access to every memory in that process, including NTDLL itself. So it is just like the hook itself installs the hook, you can unhook. In fact, you can do even better. If you're more sophisticated, you can make whatever NTDLL does, you can do that directly, sometimes referred to as a direct syscall. Because if you look at every one of these syscalls, there are a very small number of instructions, like 6 instructions or so, that put some number into the EAX register and use the syscall instruction to make the transition to the kernel. And so why call NTDLL at all? Just do that yourself without having to go through the function itself. And then the hook is essentially useless because it can't really catch that. You're just using the actual machine instructions to perform what that function does to begin with. Of course, there's a catch, not that easy necessarily, because you need to know those numbers for each system call. Each system call has an associated number. That number might be different on different versions of Windows.
It's like
So you
the
need to
IDs,
know.
right?
Yes, exactly, the syscall IDs. And so this could be different in different versions. So there are some techniques to try to get this information dynamically, but obviously it adds complexity to this way of bypassing hooks. But it's definitely possible to do.
Isn't
And it
like
has
this.
been done, in fact.
Yeah, I saw, hackers are evolving every day, and you can see techniques every single day, almost. This technique with the system calls, it reminds me with the Hell Gates, right? Hell's Gate technique where you can retrieve syscall IDs dynamically, and then you can just do a system call. So just to understand here, before we go move on the topic, as I understand, please correct me here if I'm wrong. Usually, it's we have the Windows API, and then you have a native API, and there is the direct system call, and there is indirect system calls. Is that correct?
So yeah, so essentially, if you work in any kind of language or platform, you don't have to work in C. You can work in Python or .NET or Rust or whatever. Eventually, NTDLL is going to be called. It doesn't really matter how you go about it. It will be called, and this is where the system call is going to be invoked.
Okay, so going back to the EDR itself. So you tell there is the user mode hooking and the kernel mode hooking. Usually, when I did my research and I tried to understand, usually EDRs go with the user mode hooks most of the time, because as I understand from Windows 10, I think is the kernel based hook, like SSDT, the system service descriptor table, cannot be hooked anymore, I think, with the patch guard, but maybe there is something around it. Is that correct?
So yes, the SSDT, the system service dispatch table, actually points to where the actual functions are, is protected by patch guards, starting from Vista even. This is a risky proposition trying to hook that, but there's in fact another problem with that. It's not only the fact that PatchGuard watches that and hashes the table, and the reason is that the table actually doesn't hold pointers to the actual functions, but offsets from the beginning of the table itself, which means that the target function can't be too far away from the actual table, and the only 28 bits used for that, so you can't go too far from the table. So even if you could hook that, and your driver happens to be very far in memory compared to where the SSDT is, you wouldn't be able to provide an
Right, yes.
offset small enough to get to your function. Now we can find probably ways around that as well, but this is risky, this is difficult, and most EDRs don't do that, at least because of PatchGuard. What typically EDRs try to do, the first thing they try to do is to work with official, documented sort of hooks that are provided by kernel APIs. For example, you get APIs for registering for process creation and destruction. So if you want to know when a process is created or destroyed, you don't have to go through unofficial hooks. You just need to call an API. It will call your callback and say, hey, here's a process that's been created. It's a very early part of the process creation, so you can do stuff. You can look at that process, see whether you like it or not, It's all happening in line. So while the process is being created, in fact, you can return a value there saying, I don't like this process. It will be automatically destroyed, and no one will ever know that this process ever existed. So there are a bunch of those hooks that are available by normal kernel APIs, and this is what EDR will use first because it's official. PatchGuard likes it, just like well, it likes it and doesn't really care about what's going on there. And then, if that's not enough, because you can't hook everything, there are some things you can't hook because this is something that can't really be provided, or it's simply not provided, and that's just the way it is. You don't get hooks for everything. So some cases you might want to try to hook things just like you do in user mode. It is actually possible to do, but it's still debatable whether some of these things are being looked at by PatchGuard or not. Something I'm doing a little research on as well to figure this out. Because we're not changing the SSDT, we're changing the implementation, just like in user mode, having a little jump instruction there, jumping to a different location. So from the PatchGuard perspective, the SSDT didn't really change. It didn't change.
It will not be affected, yes.
Yeah, so, but the question is, maybe PatchGuard has some other things that it's doing. Maybe it is looking at changes in kernel memory where code is, and then if you have that jump, the code has changed, and maybe PatchGuard has checks for that. I don't really know. I haven't done enough research about that, but could be interesting to see.
But usually when there is a problem, if the batch guard there is didn't check a hash or something, what I understand, there is no safe haven. It will just give you blue screen of death, right? Usually it will
Yes.
just crash without giving you any notification or warning
Yeah.
about it, right?
That's because the patch guard is stealthy. It tries to run in random times, so it makes itself harder to being disabled. And yeah, you just get a blue screen, and customers don't like it, obviously.
So Pavel, we have to find way around it. So we you make our life so hard as offensive researchers. We just try to keep finding new technique every time, and then PatchGuard will just get invoked, and this will be a nightmare for us.
Yeah, maybe. I mean, well, now there's something else called HyperGuard, which works with, if you have virtualization-based security, then it runs in Virtual Trust Level 1. It runs in the protected kernel, in the secure kernel. And HyperGuard is like a patch guard that can't ever be bypassed. And so Microsoft can definitely do things to make things harder on making changes to the kernel. And in some respect, this is a good idea. It's a good thing to maintain the stability of the kernel. On the other hand, it makes life for defenders harder, obviously. Yeah.
Even for security products, even before they were doing the hooks on the kernel mode, now they cannot with the restrictions from Microsoft. So even for Defender or for security solutions, and correct me here if I'm wrong, usually it's even hard for them. That's why they go back to the user mode hooks.
Yeah, that's one reason. It's also less risky in the sense that if something goes wrong, then the process crashes and you don't get a blue screen. So it's kind of easier in that respect. You can feel perhaps a bit more comfortable, but it's less powerful because you have to inject it to every process you're interested in. Some processes are more difficult to get into, like protected processes. So it's more difficult, I think, overall, but it has that upside. So it really depends on the particular EDR, how they want to tackle this problem in general.
And usually, if, for example, if someone want to test if this library or this DLL is hooked by an EDR or by any other software, I think you can check the first 5 bytes of the DLL in a WinDebug or something, and you can check
Yeah.
the hooks. It will immediately give you the jump instruction, or sometimes they call it the trampoline. Is that correct?
Yeah, so the jump instruction is the one that you get that 5 bytes, that the jump instruction itself, and the offset that jumps to where the trampoline function is, whose purpose is to actually call the real
The hook DLL,
the hook function. Yeah,
the hooked
something
function.
that.
Yes.
Yeah, exactly. So the first few bytes will give you already. You see that jump, say, well, that's definitely suspicious. It's probably hooked.
And the hooked function. So what the hooked function will do? It will check if it's for example, if it's harmless, it will just make the code execute. And when it makes the code execute, it will just go back to the original DLL, right, to continue the code. Is that correct? Or it will
Yeah, so
load
the
another one? Usually, it will not load another one.
no, it will try to essentially he knows which address it needs to call, so it will simply call the
Pass
well,
it.
it has that extra, the pass that to the rest of the
Yes.
function beyond those 5 bytes, essentially. Yeah, if everything is looks okay,
Otherwise, it
indeed.
will just prevent it and terminate that call.
Yeah, it will either prevent it, log something, even if it might even crash the process on purpose. It depends usually on some kind of configuration the EDR is using to how to handle cases which seem suspicious. Yeah, it's not always easy. It's not always easy because one of the things EDRs have to be careful about these false positives, trying to say, hey, here's something bad, which perhaps wasn't really bad. And if you get these kinds of cases, if you have too many of these cases, then people would not be very well happy using that kind of product. If it says, well, that's malicious, and you're saying, well, that's not really malicious, just let me do something.
It reminds me with a couple of security solutions. I cannot say the name, but it reminds me that tell you everything is is malicious.
Yeah,
Um,
it's actually, I think, one of the biggest problems of VDRs. I mean, you can say, well, that looks suspicious to me. Yeah, but then you can't do anything on the systems. You have to
yeah,
be
it will be you'll be freezed, and then you try to get rid of it.
exactly,
It's a
and you want to
nightmare.
just uninstall the security solution and say, the hell with it. I'll take my chances with the malware.
Malware. So the malware will be much faster for me performance-wise. So I think it's
At the
better
very
than
least, yeah. I mean, security products also, one of the real problems is using the resources of the host, because the machine. Because if you might have like crazy algorithms you might be able to run to figure out whether there's some kind of malicious intent there. But if you just take all lots of processing power and memory, all that stuff, again, nobody would want to use that kind of product, because your productivity is going away, even if you have these crazy algorithms going behind the scenes. So that's kind of the balance there. You want to do things quickly, but still don't be able to identify malicious intent and not have too many false positives. Definitely, writing an EDR is not easy, and that one that actually does good work overall.
so just a follow-up question to that performance. So usually, what do you recall any stories that you have in your past with the drawbacks of the hooks, like performance issues, bugs issues, that a story or things you encountered with the hooks, anything that comes to mind, or the performance bugs, any library, anything that comes to the hooking mechanism, or things that made the hooks of the system that made it so hard for the user to operate.
Well, I don't have a particular story in mind, but I mean, I'm using Windows, and Defender is usually like running, and in many cases I see that it consumes lots of CPU power, CPU percentage, much more than I would like a security product to actually consume. And this is really disturbing. I mean, this is really against productivity and makes my system go slower. And I think some products are doing a pretty good job about that. Some products not so much. And I've been part of the Windows Defender Advanced Threat Protection back then when that product started. It was the enterprise variant for. It's not the real Defender. It's not the Defender that consumers get. It's the Advanced Threat Protection, the extended Enterprise Defender. And we were at the time very concerned about that, and were really working with our own performance teams to measure everything that's going on, and not to go beyond a certain percentage, because then we'll simply be unable to deploy the product. We wouldn't be able to sign that as a protected process and deploy that properly. Unfortunately, the classic Defender still suffers from that problem, but at least the advanced threat protection for enterprise users, at least at that time, was better, and I hope it is still better today.
Okay. So I have the final topic I have for today is what are the kernel callbacks?
Right. So the kernel callbacks is again, it's really something that I just in fact mentioned a few minutes ago. That's the example of when you have new processes being created, process being destroyed. You have thread creation, thread destruction, image loads, that is DLLs or drivers being loaded into the system. You can register for these callbacks by using proper documented kernel APIs. So a driver gets called when these things happen, and you can do stuff. You know that these things are happening. There are other kinds of callbacks. For example, let's say you want to prevent a process from being terminated. How can we do that? So normally when you want to terminate a process from user mode, you have to open a handle to the process. You need to ask for an access mask called process terminate, say I would like to terminate the process, and if you manage to get a handle, then you can call the terminate process function and the process will die. However, on the kernel side of things, there's a callback for opening handles to processes. And so if you register for that callback and you want to protect a certain process from being destroyed, you can say, this client wants the process terminate, I'm going to remove that bit and give it something less than that, weaker than that. So that process is going to be protected. Nothing in user mode will be able to kill it, no matter what. So these kinds of callbacks are really powerful. Same idea as we have callbacks for registry operations. You may be able to intercept any and all registry operations and decide maybe to return a different value or to prevent certain changes from happening. So when you have these mechanisms, that's great for EDRs because it's official. There's no problem with PatchGuard. These are official APIs. The only thing you have to be careful about, as usual, is performance, and not to do too much stuff there, because, for example, registry operations happen on like crazy number every second, and if you take your kind of sweet time for every such callback, the system will start to crawl. So there's always that risk, and there's always something to be said about that. But if what you need to do can be obtained by kernel callbacks, you're in a good place because you can do that fairly easily. Unfortunately, not everything is available with kernel callbacks.
So sometimes you have to go to the user space callback hooks. There is no callbacks, so it's always hooks until is
Yeah, you have to go back to user mode hooks or even try to do kernel hooks, but good luck with that. You have to be very careful. As I said, it's something that is still, I don't have the full research on that. But yes, so for example, you want to hook memory allocation. There's no particular hook that the kernel provides for allocating memory. So if sometimes you're interested to know when the memory was allocated for read, write, and execute. Then you have an execute memory, say, well, that might be suspicious, but there's no kernel callback for that. So you kind of, well, there's really nothing you can do for that. And so you might want to hook the anti-allocate virtual memory API from NTDLL in user mode and see who is calling that, and if it's calling with read, write, execute, when, well, that's perhaps suspicious. So yeah.
sometimes, because sometimes I see people even looking at memory pages, and if they see R read write execute, whether execute pages, they will immediately say, maybe there is something fishy in there. But usually,
Yeah, it's not always
which is not the
fishy,
case.
by the way. Yeah, it's and there's no hook, so it means you might need to scan memory from time to time, which is expensive, and you can't just scan memory all the time. And even if you do, you might miss something. So this is where hooking tries to help you. And by the way, yes, if you have RWX, it doesn't mean necessarily that it is bad. For example, if you're looking at .NET or Java, they generate code on the fly. They're doing just-in-time compilation. They're taking a higher level language like the intermediate language of .NET and generate executable code. So they have to allocate memory with RWX. They have to do that, and that's fine. But again, that's the tricky part of trying to differentiate malicious intent from just benign operation and not have too many false positives. Well, life is not easy.
Yeah, indeed. So last thing I have here is we have something hot patching, or there are sometimes when we see some blog posts and they're talking about kernel patching. So can you tell us more about these?
Well, I'm not sure that I can. Well, technically, trying
Um,
to patch code or do things like that, it's something that I haven't done, and I think it's pretty risky. But sometimes there are some malicious entities that try to manipulate kernel objects directly. This is sometimes referred to as DCOM with a K, and direct kernel object manipulation, where if you have the ability to leverage some vulnerable driver, for example, or you have a driver, then you can change stuff in memory and make changes so that, for example, a process becomes a system run with system account rather than some other less privileged account, simply by manipulating a memory. So essentially, you're patching memory in a way that provides an advantage for some user mode component. And there have been such cases where you manage to leverage a vulnerable driver that allows you to read and write kernel memory to make these changes. Yeah.
Usually, when I see DCOM direct current object manipulation, I always see people abusing this by just manipulating the linked list behind it, so they can just hide drivers, hide services, and these things. But at the end, so in the end, it will be even forensically can be identified, but you still. So if you have like some applications will not be seeing it in a user mode, but
Yeah.
yeah, will just be
Yeah.
blind.
There's the linked list that manages all the processes in the
The
system.
processes, yes. Oh,
Yeah, and one of the common tricks is to remove a process from that list, patch the list, and so any code that tries to show the list of processes will miss the process.
exactly. Yeah.
Yeah,
S-
it's actually not very difficult to do, perhaps, but still, there's always a risk because when you're manipulating a linked list, there's always a lock on that list because it might change dynamically. And if you manage to change stuff that is changing in the adjacent cell, you're going to blue screen the system.
Exactly, and good luck loading the driver since with the new prevention and mechanism with Microsoft, loading a driver is a nightmare. So
Yeah,
good luck with that. Um, s-
exactly.
so, Pavel, any tips or tricks for people who want to get to Windows Internal? This is for because when I did this, when I told some people that I'm going to do interview with Pavel, so I had so many questions about how we could start researching how should because Windows Internal usually it's is hard topic. It requires you to have at least understanding of programming, understanding of C++, so you can understand when you see code, you can understand it. It will not be like something. Very bad for you, so you can at least digest it. So, do you have any tips or tricks for people who want to get to Windows Internal, how to start or how to begin with the topic?
Well, I wish I had the tricks
I
for
told
that.
I told them to go directly to your channel, to be honest, and people
Yeah, I
have
mean,
to go to your channel.
unfortunately, I don't know of any tricks. I mean, there's just a lot of things there in order to. So for one thing, I can say don't read the Windows Internals book as the first thing that you do. That will kill your enthusiasm very quickly because these are very difficult books to read. So I would suggest normally to. I'm very firm believer of fundamentals. You start with the foundation. You have to build the foundation, and yes, you have to know C at the very least. You need to understand some aspects of computers and processors to begin with. I know that many people that want to get into the security space say, well, let's try to learn how to, let's say, to reverse engineer things like that. But before you go to reverse engineering, you have to build the foundations, and there are no shortcuts. You have to do the work. I'm not familiar with the mechanism that can implant in your brain all the knowledge and experience just immediately, like something like in the Matrix. I wish there were, and maybe there will be someday, but we're not there just yet. And so my the
Your
best
advice,
thing I
yeah.
can recommend, yeah, is to build from the foundation. So when you start with the basics and you build on top of that, then you'll be able to learn anything that you want, really, because when you have a good foundation, you can branch out everywhere. If you have shaky foundations, then you'll have these holes in your knowledge, big holes, not small holes, but big holes. Then you can't really move in any I would say with certainty, with the belief that you really understand what you're doing. Another tip I can give, which is this is really a tip, maybe a trick. Always try to explain what you've learned. When you explain something, it forces you to think about it more. try to explain that in the simplest possible terms. That's one reason, by the way, that I'm teaching. When I'm teaching, I'm forced to understand something very well. If I don't, then I don't feel that I'm comfortable enough teaching that. So if you think you've learned something, talk to someone, talk to a friend, talk to a 10-year-old. Try to explain what that means. And if you're able to explain that simply, you're on the right track.
Thank you very much, Pavel. Thank you very much. So, with that, I want to tell you thank you very much for being here, and thank you
Thank you.
for the informative session. Um, I really enjoyed it, and I think the people will too. And thank you guys for sticking till the end of this episode. Please feel free to write your questions on the link below, on the comment below, or send me directly or send to Pavel directly. He's very responsive when it comes to these questions. I'll be
Indeed.
leaving his YouTube channel in the link below, so he's a good resource when it comes. It's a good resource when it comes to understanding, because he also always explain why while he code. So that's a very good thing. So it will not be a dull instructions. It will be very informative for you. So I'll be leaving that link below, and please subscribe to the channel. Hit a like if you like the episode, and I will see you in the next episode. Thank you, Pavel.
Thank you very much.
Thank you.